In my previous video, I explained what RMS values are, in regard to current and voltage, and the fact that the RMS values are used to calculate average power. This is why most measuring instruments, such as voltmeters, ammeters, and multimeters, are calibrated, or scaled in RMS values. There are some exceptions, of course, but they will be noted up front that they are not reading in RMS values. As I said, RMS values of current and voltages are used in calculating the average power and energy consumed. The power draw that a load, such as a light bulb, takes from the circuit, is expressed in watts. A load's power rating is usually marked on the device, such as a light bulb, and in this case it is a 100-watt bulb. The power in watts consumed by a load is given by the current times the voltage, using RMS values, or W equals I times V, where I is the current through the load, and voltage is the measured voltage drop across the load. Because the current in a circuit is equal to the voltage divided by the resistance, we can rewrite the equation for watts in either of the following two ways. As a final note, the standard symbol for an AC generator is not a two-ended battery, but this symbol. A simple circle with a sinusoidal wave shape. Quite often, we have to calculate the current that a specific load will draw, given its rating in watts, and we know the connected voltage. In that case, we will use the first equation rewritten as. For example, if the load were a 100-watt incandescent light bulb, and we know that the connected voltage is 120 volts, then the connected current is 100 divided by 120, or 0.83 amps. Now if the load were not a 100-watt incandescent light bulb, but a 1 kilowatt heater, then the connected current is 1000 divided by 120, or 8.33 amps. Keeping the load of a 1 kilowatt heater, and changing the connected voltage to 240 volts. Then the connected current is 1000 divided by 240, dropping the current to 417 amps. At first glance, this might seem contradictory, in that we double the voltage, and you would think that we would double the current. However, the 1000-watt heater would have to be rated at 240 volts. That is to say, that the load will consume 1000 watts when connected to 240 volts. Therefore, the connected current is given by the rated power, 1000 divided by the rated voltage, 240. Stay tuned to this site. The next nugget that I release will be a continuation of this video, where I will be diving into more detail of the essential rules. In the meantime, as a bonus and in the way of a thank you for your continued interest, I'm making available my 50-page electrical power crib sheets, if you haven't already taken advantage of downloading them. These were prepared for use with my courses. There is one section associated with each course, and are extremely valuable while viewing the course, as well as a recall of the pertinent formulas and information after the fact. The contained information is also useful during any technical career as a quick reference from time to time. Simply fill out the information requested when you go to this website. https://bit.ly/47y(3) and lastly h. As I said in the beginning, stay tuned for future releases on this site that will provide you with more tantalizing nuggets of what is available in my courses. You can also directly access my StanStore courses at this website. https://stan.store/g_V_B